So now marking has been done, that is, so this part is 25, so this small part is 10, so this part is 15, so this part is 25, so this part is 15, this part is 15, so this part is 20, and the last part is the 25. So now first we will make grooving operation. So grooving operation will carry out at 18 and 20 mm. So 18 and 20 mm are the least are the grooves, so which you have to carry out with the grooving tool. So grooving tool is being attached here. So look at the tool, how it is being attached. So after attaching the grooving tool, the speed has to be set. So for grooving, the speed has to be 210. So 210 means for J and A, the levers have to be set at J and A. So now presently the lever is at K. Now set it to J. So this lever has to set to J, and this lever has set it to A. It is already in the A position. So now we'll perform the grooving operation. So after setting the speed, that is at 210 rpm, now bring the grooving tool till it touches the specimen. Now you have to give the depth of cut. So now presently the diameter of this specimen is 25 mm. So now you have to reduce it to 18 mm. To reduce it to 18 mm, so we have to calculate the depth of cut. So depth of cut is 25 mm originally minus 18 mm that is to be cut. So divide by 2. So divide by 2 because it has to be cut in half length. Then it's 3.5. So this is the 3.5 is the depth of cut we have to give, 3.5 mm. Now so now the cross slide, the least count of cross slide is 0.0508. The least count of 0.0508 means it moves by 1 mm. So therefore the divisions to cut 3.5 is 68.89 divisions. So I have to give 68.89 divisions to cut 3.5 mm depth of cut. Now set it to 0. Now move 68.68 divisions to give cut of 3.5 mm. Till 68. So to move it to 68 and take it back again, the next step similarly. So next groove will be at this part. So this part we have to make it to 20 mm. So first touch the grooving tool to the workpiece. Now stop the machine. Now we have to give a depth of cut of 20 mm. You have to make it 20 mm. So originally this is 25 mm. So we have to reduce this part to 20 mm. So for that, the calculation of depth of cut. So 25 is the original dia. So minus 20 to be the dia to be cut. So that is 5. So divided by 2. So we have to give 2.5 mm depth of cut. So divided by the least count of this cross slide 0.0508. So divided, we have 49.2 divisions. So you have to give 49.2 division rotations on this cross slide to give a depth of cut of 2.5 mm.